6.2, radicals and rational exponents. Okay, when we're talking about a radical, it's going to be a square root or maybe a cube root or fourth root or fifth root. Okay, the radicand is the part under the radical, and there's a little number in the corner called the index that indicates if it's a square root or a cube root or a fourth root, okay, or any type of root. All right, so let's identify the index and the radicand. So the radicand here is 3, so I'll just write it like that. The radicand on this one is going to be 12x. Okay, the index is going to be 7 on this one, but hey, there's no index on this one. Well, this is a square root, and a square root's the most common type of radical we have. So if there's not an index written, it's assumed that we're going for a square root, which means the index is 2, because we're looking for something multiplied by itself. So multiplied by two pieces multiplied together, raised to the second, that's going to equal the radicand. So here, if there's no index written, the index is 2. There's a hidden 2 up there, okay? All right, let's write nth roots as a power of n. So here we have an nth root of a, and that can be written as a to the 1/nth, okay? A rational exponent is an exponent written as a fraction. Okay, so if you're asked to write a radical using a rational exponent, you're going to want to convert it into something to a fraction, raised to a fraction. Okay, so if we're following this format, the index here is n. That's going to become the denominator when we convert this into this form. So the radicand is my base, and then that's going to be raised to the 1/8. So 7 to the 1/8 is actually equivalent to the 8th root of 7. Okay, this is going to be x to the 1/3. I'm always doing 1 over the index for these ones. Okay, and it's tempting on this one to write that, and that's almost correct, but there is a little mistake here, and it's an important mistake though. So when I write 2x to the 1/5, only the x is raised to the 1/5. The 2 isn't. It's really 2 to the first times x to the 1/5. That's not what I want. I want this whole radicand to be raised to the 1/5. So I want to put parentheses around the 2x, and that's an important distinction because that shows that both the 2 and the x are getting raised to 1/5. Okay. All right, let's look at real nth roots of a. If the index is odd, so if I have an index of 3 or 5 or something like that, then we're going to have one real root. But if you have an even index, like an 8th root or a square root or a 4th root, there are going to be 2 real roots. You're going to have a positive root and a negative one. That's why that plus minus symbol is there. There are special situations. If the radicand is 0, so if you're taking the square root of 0 or the cube root of 0 or the 17th root of 0, it's always going to equal 0. So there's always one root if the radicand is 0. And if you've got an even index when the radicand is negative, then there are no real roots. So let's think about that for a second. Let's say we're taking the square root of negative 9. Well, I need something times itself that equals negative 9. But 3 times 3 is positive 9. Negative 3 times negative 3 is also positive 9. So there's no number that you can raise to the second power, no real number, and get a negative number. So this is going to have no solution. It means it has no real root. Okay. All right. So let's find the indicated real nth roots of a. So the nth roots of a, that means the 3rd root of negative 125. So let's figure this out. Okay, so I want something raised to the 3rd power that's going to equal negative 125. Just to do a little side problem, if you think about, let's just say negative 1 raised to the 3rd power, it equals this, right? So negative 1 times negative 1 is positive 1. And then when you multiply that out, it comes out to -1. So when you take a negative number raised to the third power, it's always going to come out negative. So I know the third root of -125 is going to be negative. So it's okay to have a negative number underneath a cube root or a fifth root or a seventh root, but you don't want one under a square root because the index is even there. Okay? So now I need to just figure out what raised to the third power is going to equal 125. And when I see 125, I think of money. I think of 5 quarters. And 1 quarter, 25 cents, is 5 times 5. So 5 times 5 times 5 would be 125. Okay? So that means -5 to the third power is going to be -125. And you could use a calculator to figure that out. You could just do some trial and error would be one way. Or you can use, if you have a fancy calculator, you can do a third root as well. So one of these calculators, if you hit this math key, and then the cube root is the fourth option down there. And then I put a -125. But just be careful when you put in -125, you don't want to use this minus because that's subtracting. We're not subtracting, we're using negative, so we're going to use that negative button. So when I hit that one, hit 125, whoops, and hit enter, then it tells me -5. Or I could take -125 and raise it to the 1/3 because that would be the same thing. So when I want to raise something, I'm going to use this little, that was just a mistake there. I'm going to use this key here, little arrow up, and then to do 1/3, I just hit 1 divided by 3, and that comes out the same way. When you have a negative number that you're raising to a power, always a good idea to put it in parentheses, because some calculators, if you don't use the parentheses, they'll do the exponent first, then multiply by -1. And so your answer will come out wrong half the time. On this one, it wouldn't make a difference. But okay, so nth root of a, so the 6th root of 64. Okay. Now this one, since it's an even index, if you look up here, we're going to get a positive and a negative answer. Okay. So what I'm going to do is just think, well, what raised to the 6th power equals 64? And I'm just going to do this with a little trial and error. So I'm just going to try out, okay, 2 to the 6th. Hey, that's 64. I hit the lottery there right away. But, you know, you could plug in some different ones if you needed to. Whoops. So I typed in something weird there. But you could just play around with it. But, yeah, I can see 2 to the 6th. So 2. But then if you take -2 and raise that to the 64, and I'm putting that in parentheses, not to the 64, -2 to the 6th, sorry. That also equals 64. So positive 2 to the 6 equals 64, but so does -2. So that's why you've got 2 real roots there. Okay? And it's a little strange. You would think when you're evaluating, you do the same thing with the plus minus, but the positive root, we've got a positive root and a negative root. The positive root is called the principal root, and when we're evaluating an expression like this, we're usually just finding the positive root, the principal root, okay? So when there's an odd index, there is only one root, and it's going to be negative here because a negative number to the third is going to come out negative. And then I'm thinking what raised to the third equals 27? Well, 2 to the third is 8. Let's see, 3 to the third, 27. So that means -3. So try it out. -3 times -3 times -3 will come out to -27. Okay, you don't have the plus or minus because if you did positive 3 to the third, it would be positive 27, not -27. Okay? All right, 16 to the 1/4. Let's evaluate this. Now you could actually just type it into a calculator like that. You could even do 16 to the 0.25. But I'm going to think of this as a radical. So the 1 would be, this is the radical form of the same thing. So now I've got the 4th power of 16. And I'm only going to use, even though when they're saying find the real nth roots, you would do the plus minus thing here with an even index. When we're evaluating, I'm just going to give the positive one. So I'm thinking, okay, 4 times 4 is 16. So that means 2 times 2 times 2 times 2. So 2 to the 4th. So that means we've got 2 there. Okay. All right. Rational exponents. So I showed you how to, we haven't seen how to deal with an exponent. So here we've got this m exponent, and it's just going to be the numerator. So we did once where the numerator was 1, and that means this exponent would be 1. But when you raise to the first, it doesn't really do anything. It doesn't change the value, right? But you might have a rational exponent where the numerator is not 1, like this one. So all you do with this, the 3 will still be the index, and the negative 64 is the radicand, and then the 2 is going to be an exponent. And you can decide. You can put the exponent inside the radical like that, or you can put it on the outside, so you could raise this whole thing to the second. Okay, and you can take your pick. For me, I'm going to use this second version here, just because I don't want to take negative 64, and raise it to the second, because it would be a really large number. So I'm thinking maybe I can even play around with this. Even if I didn't have a cube root button, I can think what raised to the third is going to equal negative 64. I know it's going to be a negative number, right? So let's try negative 2 to the third. And that's okay. Let's try negative 3 to the third. Nope. Let's try negative 4 to the third. And hey, I got a winner there. So this part is negative 4. And then I'm going to square that. Well, negative 4 squared is positive 16. Okay, let's try another here. The denominator is the index, and then I've got 256, and you can choose where you want to put the, I don't want to raise 256 to the third. I'd rather simplify this part first and then raise that to the third. Okay, so let's see. Let's play around. So something to the fourth equals 256. Let's see, 2 to the fourth. Nope, 3 to the fourth. Nope, 4 to the fourth. There we go. It's going to be 4, right? So this part simplifies to 4. Got 4 to the third. That is going to come out to 64. Okay. All right, let's look at another here. I've got negative 16 to the 1/4. So my index is 4. Negative 16 is the radicand. 1 would be an exponent, but it doesn't matter because raising the first doesn't change anything. So, hey, I know I'm going to need a negative number raised to a positive number raised to anything is always going to be positive. A negative number to the 4th power, well, I'm taking a negative number and raising it to an even power. Well, that will come out positive. So this is not going to work out. Like if you think about the square root of negative 16, well, negative 4 times negative 4 is positive 16. The same thing will happen if you multiply a negative number together 4 times. It's going to come out positive. So this has no solution because the radicand is negative and the index is even. That's always going to happen in that scenario. That was one of those special situations from the last page. Okay, and then 9 to the 5/2. Well, that would be the square root of 9 to the 5th, and I'm going to put the exponent outside like that. Hey, square root of 9 is just 3. So I've got 3 to the 5th. I'm going to use my calculator to help me find 3 to the 5th. That equals 243 then. Okay, and that is the end of the section, and I'll see you next time.